Okay, good afternoon from Perth, Australia, and welcome everyone to today's HYPACK webinar. My name is Justin Stockley. I'm the Xylem Analytics Surface Water Manager for Southeast Asia and North Asia. I'll be doing a very short introduction and then handing over to our two presenters for today's webinar. So just a couple of things to bear in mind. If you do have questions as you're watching and listening to this webinar, please do type in those questions. There should be a chat box on your screen that you can see. And at the end of the presentations, we will have a question and answer session with the two presenters, and we'll try to get through as many of those questions as possible. The second thing to be aware of is once we've finished this webinar, you will receive an email, and that will have a link to download a recording of the webinar, and also a link to generate a PDF certificate with your name indicating your attendance at this webinar, because I know some people need that certificate. Could I jump to the next slide, please, Boris? So today's the webinar today is about HYPACK, obviously, and SonTek, two Xylem brands. So HYPACK has been making survey software since 1984, so they're almost up to 40 years in the business. They're originally called Coastal Oceanographics Hydrographic Package. They shortened that to HYPACK, thank goodness. And I'm also told the whale logo was originally drawn by one of the original programmer's daughters. So their main office is in Connecticut in the US. And then the other Xylem brand that we'll be referring to in this present webinar is SonTek, which is a derivation of sonar technology. And they've been manufacturing acoustic Doppler current profilers, ADCPs, and acoustic Doppler velocimeters, ADVs, for more than 25 years from their manufacturing facility in San Diego. Next slide. And basically what you have is the software, which is HYPACK, and the hardware, which is the SonTek M9, and together there are Xylem complete solution for undertaking bathymetric surveys. Next, please, Boris. And so I won't go into the hardware into too much detail because that's probably a webinar in itself, but I just want to highlight that the SonTek M9 is different from most echo sounders. It's not just measuring depth and range to the bed, but it's also measuring the water velocity and profiling water velocity. And next slide. And so when we using the M9 to measure discharge or flow rate in rivers, we refer to that as the M9 River Surveyor. When we do that measurement, we use a software called River Surveyor Live, which is a SonTek developed software. And essentially, the ADCP is determining its position, the depth, profiling the velocity, and moving across the river to then compute the discharge or flow rate of that river. And the second slide, please. And now when we're doing a bathymetric survey using the M9, so the same hardware, but we're using the HYPACK software, we refer to that as M9 Hydro Surveyor. It's the same software. It's the HYPACK software, it's the same hardware, but the hardware is functioning differently depending on the different applications. And I've listed most of the differences there. I just want to highlight the ones in red. And then when we're measuring discharge using the River Surveyor Live software, most of our pings are being dedicated for velocity measurement. When we're in Hydro Surveyor mode, the hardware is dedicating more pings to depth measurement because obviously for bathymetric surveys, depth is more important. Next slide, please, Boris. And just my final thing I wanted to mention is we have a great series of videos on the SonTek website. It's 10 videos done by our senior hydrologist, Daniel Wagner. Each video is around 5 to 10 minutes long. And it takes you right through setting up a HYPACK project, the geodesy, line planning, doing the survey for an M9 using the M9 hardware. So it's a fantastic resource. And like I said, it's 10 very detailed and thorough videos. And the next slide. Okay, so now we will get to our main part of this webinar, and I'll just quickly talk about our two presenters we have today. We have Boris Shulze, so he's our international sales manager for HYPACK. Loads of experience with multi-beam surveys, application and software, and obviously HYPACK. He's going to be doing most of the heavy lifting in today's webinar, and he's going to be highlighting the features within HYPACK that'll make help to make your SonTek survey better. After Boris, we'll have Phillip Thomas. Now, Phillip Thomas is based in Singapore, and he's the operations manager for a company called Sea and Land Technologies. Very highly qualified and certified surveyor. And Phillip's going to finish up the webinar today with some high-level thoughts around single beam surveys and some tips around planning your survey. So with that, I hope you all enjoy this webinar coming up, and I'll hand over to you, Boris.
Thank you, Justin. Yeah, welcome everybody to this webinar. As Justin said, my name is Boris Shulze. I'm German. You probably hear it by now, and I will guide you through tips and tricks of HYPACK. Before I start, I would just like to show you a poll that you can fill out on the screen. Can we see the poll? If you take a minute or a few seconds rather and fill out what you see there, and whatever you see there, please just tick on what is applied to you. Are you currently using bathymetric survey software? That's the question really for us. So we know if you're familiar with HYPACK or if you are new, we would like to know the audience. And we should see the results very soon, hopefully. We give you like 15, 20 seconds for this. There you go. So I can see half of you know HYPACK. A couple of guys are new to it. Some use other software. Oh, I didn't know there's other software. Okay. Okay, and 40% want to use the next software. Okay, let me carry on then. Okay, some background for HYPACK. Yeah, as Justin already said, HYPACK integrated the Hydro Surveyor M9 and the Castaway CTD. So we worked together really hard for a long time to make that happen. HYPACK comes from the hydrographic industry. So our software does everything from survey planning in the office, then you go out, do your data collection, and come back to the office, do your post-processing, and whatever your final product is, if it's a electronic chart, if it's some DXF output, whatever, we do the final product. So no need to go to any other software. You can do everything you want to do in a survey in HYPACK. We can create contours, cross sections, calculate your volumes if you are surveying a reservoir. You can do volume changes over time and many more features. I can't show you everything because HYPACK is a very, very powerful tool. We not only do the SonTek Hydro Surveyor, we have more than 400 different sensors, and you can combine them all. You can combine bathymetry, topography, LiDAR now, and you can combine this into a map and then export this map into CAD, XYZ. If you want to use another software, Google Earth, for example, is just something that a lot of people use, and I will show you later on how the exporting Google Earth works. As I said, we have hundreds of sensor interfaces and generic drivers. Virtually every instrument that's out there, we can connect to it. Yeah, just like to give you some support information. Our software does not only work in English. We have 24 languages at the moment. We have a language base, and we are adding more and more languages when it's required. You can do your own language if you like to. So if you want to do some weird language, fine, you can do it. We have the HYPACK manual, which comes with every installation, but as it says here, it's 2,602 pages, quite large. That's why we have the help menu. This is like a searchable online manual that can help you finding whatever you're looking for. Every 2 months, we bring out a sounding better article. Everybody who works at HYPACK is posting an article on our website. It's kind of interesting, technical articles, what's going on at HYPACK, all that kind of stuff. It's kind of funny to read. So if you have a minute, go to our website, download the articles and have a read. Yeah, when you have some trouble with HYPACK, we offer BOMGAR and TeamViewer support. They are both built into HYPACK. So whenever you have a problem, you just go to help, click on a button, and then you have the TeamViewer, for example. And you can actually have a technician log into your computer and he helps you with your problem, taking remote control on your PC. We have lots of videos on our website and on YouTube. We have our own YouTube channel. You see the address down here. So when you have the recording, you can click on it and you can just check out our videos. There's, I think, like 128 videos at the moment. And of course, we have a support hotline. So whenever you want, you can contact support for any question, or us if it's sales related. We do a lot of training as well, on-site trainings, installations, and customer programming. So if somebody has a new instrument that he wants to connect to HYPACK and we have not done it yet, we do certainly a programming on it. So we do more than 400 days all this per year. Yeah, and there's a lot of knowledge articles on our website, which are really kind of useful. I can show you a picture here. I just went to our website and just typed in SonTek, and this is all the literature you find about the SonTek. So there's a manual, a quick start, tips and tricks, all that kind of stuff you can just download for free from our website. Okay, let's go into the software. The shell. So this is when you start HYPACK, this is what it looks like. This is the main program. We call it the shell, because it's the shell, and from here on you start all these different software packages or programs, so to speak. Let's start. The first thing, that's kind of a nice tip and trick, importing web maps. A lot of people use web maps in these days. There are servers around the world, every country has them normally. And you can download maps from the internet. So there's no need anymore to digitize a paper chart or, or download Google Earth and trying to georeference it. The only downtime is that some are free, some are not. So a lot of people charge you now for these web maps. But OpenStreetMaps, that most of you probably know from their mobile phones. Everybody who has an Android phone uses OpenStreetMaps. They have a server and their charts are free. So I'm going to show you the how you can add an OpenStreetMaps server into HYPACK and download maps for free. I've recorded a video because the online, if I do this right now here in real time, it's kind of hard to do it, to download charts and talk to you guys. So I'll just record a video that I'm going to show you and I will speak to it. So this is the video here. So we have the HYPACK shell, and I have, here's a little lake that we want to survey. Just as a mark, I've done some lines in the middle here. And now we want to add the server, the OpenStreetMap server. So what we do is this. We have to go to View and show the Web Map Server interface. So the Web Map Server, and then we add a Web Map Server, we call it OpenStreetMaps. We have to give it a service type, which is the TMS. So OpenStreetMap, there's different servers out there. I don't want to be too technical, but they all work in a different way. OpenStreetMap is a tile map service, so a TMS server. So you have to enter the server type, and then you have to enter a URL, which is OpenStreetMap. And then you can do a test connection. It comes back, every server comes back with some weird answer that you see down there in the text box. As long as you see something, that's fine. So you just press OK. So now you have added the server. Now we want to download maps from it. So we go to the map editor, we select the server, OpenStreetMap, we select the area. So what we want to do is we want to download the area in the blue. So then we select a scale. So depending on the area, you want to do a large scale or small scale. So I selected here 1 to 8,000. And now I'm downloading the charts. I'll search this query here. I'll just stop the video. So we can repeat that search if we want to later on. And now we are going to download the charts, and there are the charts. We can close the editor and we can look at the charts. You can see they're a little bit transparent at the moment. So we're going to change that. We go to the background to OpenStreetMap, ask query, and then we go to transparency and we can change the transparency. You can see how nicely it comes in there. See, they're now less transparent, more. So you can play around with it, make it match, and you see it fits nicely to our survey area. You can switch them on and off very easily by a click. So this is like how you import web maps. This is just an example. OpenStreetMap, as I said, is a free web server. You can use it. There might be some in your country that I don't even know of, but yeah, use them. They are a lot of help when you plan a survey, to see the area, to see where you are. And before somebody asks in the question and answer session later on, no, we cannot do Google, unfortunately. Google does not allow to do web maps. If you want to use Google Maps, you have to make a screenshot, georeference it in HYPACK, and show it as a background. We cannot do web maps yet. Google does not allow this. Right, let's go to the next one. Oh, sorry, that's not the next one. Yeah, another nice feature in HYPACK is adding software links through the tools menu. Sometimes you want to, especially when you work with the SonTek M9, you have to access the SonTek software to do some upload, download, whatever. So we have a tool that allows us to start external programs out of HYPACK. This is done in the tools and setup. I'm showing you a little video here as well, how to add the SonTek utilities. So tools, setup, I go add, give it a name, SonTek utilities in this case. And then I have to point to the program. So I have to find, it's in the utilities, in HYPACK, in the support. You find the SonTek utilities. So I just scroll down, there they are, open them and say, okay. So now they are added. I can close this again. And when I go to tools and I'll click on SonTek, it will start the SonTek utilities automatically. So no need to go into a Windows Explorer, find the SonTek utilities and open them. You can add any software you want in this toolbox. You can even do PowerPoint if you want. Yeah, this is the SonTek Utilities program. Most of you probably know this already. If not, you can watch the webinar from Daniel. The SonTek Utilities, why is it in HYPACK? Why is it important? Very simple reason. When you use the SonTek M9, you have to do a compass calibration before you can use it. So every time you go out there and survey a lake or whatever, you can do the compass calibration out of HYPACK. Open up the utilities, click on compass calibration, and then follow the instruction on the compass calibration. So you can calibrate the compass. You can do as well a beam check, which is always useful to make sure that everything is working fine and you're receiving a nice echo from the transducers. Yeah, a lot of people ask us about the color palette. Once you have a survey, you see here's a little survey. This is actually a Google map picture here, and then you see a lake here and a surveyed lake. The colors are not really nice here. So we have a color bar on the left, but we don't see any numbers on it. So it's kind of not really set up. So how can I change the color palette? That's pretty easy. I'm going to show you in a video. So first you show the text. So that gives me here text, and that's in meters. And then I can set a band. So I set a minimum of 0 meters and a maximum. That's my maximum water depth. And I set an increment. For every color, I set an increment. So I said, okay. And now I have a color bar. My color bar here at the left side shows me all the colors and the range of the colors. When I press the apply, it will apply this immediately to my data that's visible in the map view. So you can see it changes. It's not quite there yet. So 25 was maybe a little bit too much. So I'm going to 10, and I change the increment to 20 centimeters. When I press apply again, this is a much nicer view now, and I can see more features in the lake. You see this blue spot in the middle of the lake. There seems to be something there. So that's how you can change the color palette very quickly and very easy. Oops, sorry. Okay, next one, preparation. Before you can go out for a survey, you need to prepare yourself, of course. Most people, you'll know this already. You need to set up the hardware, you need to set up geodesy, you need to get ready for the survey. You can do this in the office already on your computer. So most of the things you want to do it in the office, don't do it on the boat. It's rocking and rolling and you lose time on the boat. So do it in the office the day before. I'm going to show you some tips and tricks. I can't go through everything. As I said earlier on, this is more like tips and tricks related here. The general basic operation of HYPACK is covered in lots of videos and webinars. So I'm just concentrating on some extra things that most people may not know or always ask themselves, how does it work? Okay, let's go and start. When you set up the hardware in HYPACK, you have to set up the SonTek M9, of course. When you set it up, this is the hardware pop-up. You can actually test the M9 right out of the hardware. Once you do the hardware connection to the M9, you can go to the options, and then there's the SonTek utilities. And if you click on this one, it opens up the SonTek utilities, and you can go right in there, make a connection to the hydro surveyor, and check if it is working fine for you. So that's something a lot of people don't know. They always go out of the hardware, set up the hardware, close the hardware, go into the utilities, a lot of steps. So this one is a lot easier. If you just right click from the hardware, when you set it up, click on SonTek and check if the instrument really works for you. Yeah, another nice driver that you might want to set up is the HYPACK coverage track. That's a driver that you can add to your existing setup. Why do you need that? You don't really need that, it's an optional thing, but it's kind of nice because, as you know, the hydro surveyor has a 50-degree swath coverage, and when you go along on the lake, you want to know how much coverage do I have? Did I really cover everything? Do I have gaps in my data? This is where the coverage track comes really handy. If you set it up, you just set it up the swath angle 25 and set it to depth controlled swath. So when you go deeper, your swath covers a wider area. If you tick this one on, HYPACK will calculate the coverage on the seabed. So in the map on the right, you see there's the boat, and the red one, the red bar, that shows you the coverage you have with the hydro surveyor. That's the area you have covered. So in here, in this case, you see the gaps between the yellow, which is already done, and the red one, which is the current line. So you see here we have some gaps, and we would have to go back and fill this in if we want to have 100% coverage. That's kind of a nice feature that really helps while surveying. Yeah, plan lines. So I planned some lines on my lake. You see, I've done this already here. I've planned a couple of lines, but now my boss asked me, hey, how long does it take to do this survey? When are you back? Can you do this in a day or two, or give me some estimate? A lot of people struggle with this. So we have added a very nice feature here that I'm going to show you in a video. So this is we call it the line report. So this is my line editor where I have all these lines in there. And there you see the line report. If you click on the line report, it will allow you to enter a survey speed and a transit time. The transit time is the time you need for a turn from one line to the other. It's just an estimate. So you enter your general survey speed. I'll just put in 1.5 meters here, and the transit time 1 minute. So I say okay, and immediately it gives me a report. So this report shows me that my total line length is 6,300 meters. It takes me about like 2 hours and 22 minutes to do the survey. My transit time, so my turn time from one line to the other, is accumulated 18 minutes. So the whole thing takes me like 2 hours, 40 minutes. That's not too bad. So with this line report, you can easily calculate how much time you would have to spend out at the lake or the sea. So, and you know, okay, I can do this in a day, or it might be a multiple day survey. That's kind of a very handy and useful thing to do before you go out for the survey. Okay, that brings me already into the survey. We've done the preparation, we're ready to survey. So let's look at the survey screen. Not a lot of people know about this, but we have a log sheet. Usually when people go out and do a survey, they log whatever happens on the boat. So they note down the start time of the line, the end time of the line name, the line azimuth, all that kind of stuff. So there's a lot of writing involved. To make that easier for you, we have a survey log sheet creator. This one can be started automatically with the survey. So every time you start your survey, it starts automatically with it. And the nice thing, it fills in most of your data for you. So it fills in the start time, the end time, whatever you want it to have, like line azimuth, file name, it all populates the survey log sheet for you. So you can concentrate on maybe some additional information that you might want to put in there. That is a very nice feature, and at the end you just export it as a PDF and you can print it. So it comes with your data and gives your later on, maybe a year later, you look at the data, what the hell was going on there? You can just look at the survey log and it tells you something that you wrote down at that time. So it's kind of a nice feature that you should use, at least try out. Yeah, this is during a survey, the typical layout of the survey screen. You see the map with a boat, you see a planned line there in red, and then you see the pictures of the M9. So this is how the M9 survey actually looks like. You see the 5 yellow dots, that's the transducers. The number inside shows you the transducer number and the depth. Let's look at these displays in more detail. So you see depth display, you see the 5 beams that we are using, and you see the 5 lines are the profile of the bottom here over time. On the right side, you see the bottom track. You can switch between using the bottom track of the M9 or using your GPS. Both is possible in HYPACK. You just have to click it, activate it, and start recording again. Another nice one is you can watch the velocity. You see there's the bottom one shows the velocity. While you're surveying, it shows you the depth profile and the velocity at the same time. Yeah, when you want to use bottom track for positioning, that is possible. A lot of questions from our users come to this. Yes, you can use it. You just activate it by clicking on use bottom track, but remember you have to start a new line when you do this, because we cannot combine bottom tracking and GPS. That is not possible for technical reasons. And remember, use your log file to make a remark. Bottom track used for this one. So later on, you know where you use bottom track in the processing and where you use GPS, because the accuracy of bottom track is apparently not as good as with GPS. Yeah, we have another new nice feature in HYPACK. That's the HYPACK playback. So once you're back in the office, you may want to show your survey to your colleagues or your boss. You simply can replay your survey in the main shell. You just click on the playback button, and then you just playback, choose the file that you want to play back or the log file, and that plays back all the files that you have recorded and shows you this ship moving on the screen. Yeah, that brings me to the last one. That's the processing. Processing, now we have recorded our data and we want to process this data and make a nice use of it. So let's have a look what kind of tips we have here. That's the data flow, the general data flow. So once you record your data, either by running HYPACK or just the hydrosurveyor data, which is a different file format. It's called the YDFF. And they all go into the single beam editor. This is a standard program in HYPACK, and you can edit your data. And from there on, you clean your data, you apply ties, or whatever you want to do with the data. Once it's edited, you can make a model out of it. That's what we call the TIM model. Or you can plot it, or you can calculate volumes, or do cross sections, or you can go straight into an export. Or you go further on and do contours, volumes, or 3D models. I'm going to show you this. Data processing. So in general, there's two workflows to process your data. When you collected your data in HYPACK, the data is called raw. So this data goes straight into the single beam editor. You edit the data, and then you put it into final products, which is a modeling or volume calculation or whatever it is. Simultaneously, we collect the SonTek raw data file, which is called the YDFF. The YDFF cannot be read by HYPACK directly. You have to convert them before you can use them. So in HYPACK, we have a data converter that converts the YDFF into raw, and then you can put them into the single beam editor and final product as well. Why do we do this? The YDFF files are kind of useful if you want to look at flows and you want to look at discharge and that kind of stuff. So that's why we simultaneously collect them. And if you have some old data, YDFF data, you can always reprocess them using HYPACK. That's another nice thing. Yeah, so if you want to use the YDFF data, you use the side scan data reformatter. You just click on the program. It's included in the in HYPACK, and you can just open your YDFF files, click on convert, and it converts them into HYPACK file format. So pretty easy to do. Okay, this is the single beam editor that you see here. This is where you edit your data. When you load all your data, this is the same lake that we've seen before. It shows me all the beams that we collected. You see there's corrected depth 1 to 9. The M9 has 9 beams. That's where the name comes from. So I'm showing all the beams here. A lot of people don't want to see all the beams. Maybe you would just want to see the central beam. So you can actually switch off any beam you want and just leave the center beam is number 5. So leave number 5 in there and use it as a single beam echo sounder. So this way you have total control over the beams that you want to process here. Yeah, you can look in the single beam editor, you can look at the data files, not only in depth mode, but you can see actually the single file names here. So every file has a different color. That way you can easily check when you have a bad line or bad line steering. If you don't want to use this line, you can take it out of the survey and out of your processing. You can as well, this is a zoom in of the data here on the right side. You see the data is not only a point, it's actually a number, color-coded number. So this is the depth, like on an electronic chart. You see here the depth in numbers. Yeah, in the single beam editor, we have a spreadsheet output as well. So if you like spreadsheets, you can put your data into a spreadsheet. So you can configure the spreadsheet. You can do whatever you want to do, time, GPS, X and Y, and then you can see all the depth of your transducers. So you can use that one. You can actually output this one into Excel if you like. So we can export directly from here into any other program. Yeah, that is a typical 3D view of the soundings in single beam editor. A very nice thing that not a lot of people use. There's a mouse and keyboard cheat sheet that you can pull up from the edit menu here. This allows you can do a lot more with your mouse and your keyboard what you normally see. Have a look through this cheat sheet. It allows you to move this model around, play with it, enlarge the exaggeration, a lot of things. It's kind of a very nice thing to look at and check it out. Yeah, whenever you load your data, don't forget to account your magnetic declination. This is where you enter your magnetic declination. You can do this in post-processing. You can change that as well when you find out, oh, my magnetic declination wasn't right. You can always go into your data, into your single beam editor, and enter the magnetic declination in the heading here. That's whether the red circle shows it. The magnetic declination is different everywhere in the world. So I use an app on my phone which shows me the magnetic declination wherever I am, which is kind of nice. So I just use that one and enter it in the single beam editor for processing. That corrects my heading angle for true north. Yeah, another nice tip is view your survey nodes while you process the data. So that's why survey nodes are really important. If something happens, you go on a straight line and suddenly another boat comes from the port side, you have to stop the line, interrupt the line, and start again, maybe. So that kind of stuff you can write down in the survey notes. And when you do your processing, or while you do your processing, you can pull up the survey notes just by clicking on the survey notes, and whatever you've written down electronically in HYPACK, you can show there. And it might explain why the data looks so weird. We have some smoothing options as well. This is a typical profile of this lake here. And you can see there's some wiggle on the bottom here. Every time you see waves, that is a heave movement, and that might influence your sounding. So you can actually, if you don't have a heave sensor, you can actually filter this out. This is why we have the smoothing options. And I'm going to smooth this file here, this profile here. And you see how smooth it is now. So we got rid of a lot of heave artifacts in this data just by simply smoothing this. Yeah, the single beam editor allows you as well to pull up a flow window. In the view, you have a flow window. So at the same time you're editing your bathymetry data, you can actually look at the flow. You see the flow in here. This is cross profiles through a canal, and you can see the flow. You can set the vector length, you can set the vector width, you can average it over how many samples you want, and you have different averaging methods here. So this is kind of a useful tool if you are mapping a canal or a reservoir and you want to know where's the water intake. So at the end, we have to do a final product. So what is a final product? It can be anything. And we have lots of final products here. I'm going to show you some tricks and tips here around the final products. The first one is the ADCP profile, which is another program that is included in HYPACK. That's why the YDFF files are really important, and that's why we collect them. So you can always load the YDFF file into the ADCP profile software. So this shows you an ADCP profile of your area, and you can nicely see here the flow and the different magnitude here. So it's kind of a nice edit function. We cannot calculate discharge though, unfortunately. Work on this one, and maybe in the future we will see that. But back to bathymetry. Your bathymetry data needs to be gridded. It needs to be put into a digital terrain model. We call this TIN, triangular irregular network. So once you finish your editing of your data, you can go straight into the TIN program, which puts it into a model, nothing else. So you see on the left side, this is a two-dimensional model of an area, and you can cut sections and profiles through it. So you see profiles, and you can export this, of course. You can do volume calculations in there. You can do 3D models as well. So I'm going to show you some more. This is a 3D model that I've done yesterday of a harbor in the US. I just simply did a river surveyor survey, calculated a model, and used a GeoTIFF to overlay it, and exported it to Google Earth. The picture on the bottom right shows you Google Earth. So I just downloaded this one to Google Earth, and I can send that to my colleagues if I want to. It's a KNZ file that you can send to everybody, and he can look at the data. It's kind of nice. Yeah, you can export contours as well. So HYPACK allows you to specify contours. If you're not interested in pretty pictures, but you're more interested in contours, that's no problem. We can export the contours as DXF. So there's a export DXF contour dialog in HYPACK. You can highlight and isolate in contours as well. So if you're interested in a special contour, you can mark that one with a different color, make it thicker. So it exports in a specific contour for you into a DXF file. We have a web export, which is kind of a nice thing. If you want to show your data to your customers, you don't want to give them the whole data set maybe, or they don't have HYPACK. So we can export a HTML file that you can send to your customer, and he can just open it up with his browser and look at the data and turn it and tilt it. I've made a video of it, and I'm going to show you the video. So I'm exporting the data into the web. I just choose a folder. I put this. So I'm exporting it now. I'm trying to open up a browser. Sorry, a Windows Explorer. So there's the file. It's called index.html. I just open it. It opens up my browser. It shows me my model that I've just done. And I can turn it and tilt it. It's like a 3D virtual tin in my browser. Kind of nice. And you can send that to your customer. The tin program allows you to calculate volumes as well, especially for people that work in reservoirs. They want to know how much water is in my reservoir. So they do a bathymetric survey, and afterwards, okay, now I have my model. I need to know how much water will be in this reservoir. You can calculate that in the tin program. You simply just click tin to level, and then calculate to specify the tin to level intervals from 3 meter to 25 meter. Every meter I want a volume calculation. I've done this here for you, and you can see that, and then you can calculate and export a PDF report, and it shows you on the bottom left screen, the bottom right screen, you see the depth, you see the volume above my 3 meter, the area above, the volume below, and the area below. So you can calculate any volume above a certain level, or how much volume is in the reservoir. It's a very nice feature, especially for people that want to know how much water is in a reservoir, or how much water it can hold. And especially when over time the sedimentation rate in a reservoir might be larger, and you want to know how much water capacity I'm losing here. Okay, I want to quickly show you some water quality data, processing water quality data. But before we do this, I want to know how much people are really interested in that. So we've made a little poll here for you. Are you interested in water quality processing and visualization in HYPACK? If you can answer this one for me, we can look at it, the result in a few seconds. That's kind of interesting, because we always ask the users, where should we go? What should we put in HYPACK? That's always a big discussion at the end of the year. What do we do next year? So we always like to ask our users, what do you want to see? So if many of you click now, yes, we might do a water quality processing in HYPACK. So let's see. 97% want to say yes. So you're on my side, guys. I like you already. So yeah, so that's very good. I love that. So I'm going to show you what we can do today. So this one is some data. I'm not a hydrologist at all. I'm a geophysicist, so I'm struggling here maybe with the words. This is a dissolved oxygen map. Shows you the oxygen content in the water. That was mapped, I think, with an EXO, but the Xylem EXO sensor. So you can import that data into HYPACK very easily. You can actually import any XYZ data into HYPACK, no matter what it is. We don't care, as long as it has a position and Z is a value for us. We can display that value. That's the beauty of it. So you can overlay your bathymetry with any environmental sensor that you have. Yeah, as I said, importing water quality as XYZ, you can do that easily via the utilities button. You click on geodesy, geodetic list conversion, and then you have to specify what kind of format is your data in. So it needs to have a position. So easting and northing, lat long, and some depth value. So this program allows you to specify what's in your data, what's the resolution and the decimal precision, and then you can simply load the data into HYPACK and plot it. I'm going to show you some samples here. This is from a YSI turbidity sensor, fluorescent dissolved organic matter, NH4, and turbidity. So on the same lake, we run an EXO and collected all these parameters at the same time, and we can plot everything in HYPACK. So no need to use other software. You can completely use it, completely do the processing in HYPACK. Same way you do the processing of your single beam data. Right, that's the end of my presentation already. Time is running fast. So I'd like to hand over to Phillip here.
Hi, everyone. My name is Phillip, and thanks, Boris, for handing it over and for your part of the presentation. My name is Phillip Thomas, and I'm from Singapore, and I have been working as a hydrographic surveyor for approximately 10 years now. I'm also the operations manager for Sea and Land Technologies in Singapore. So for today, I will be going through certain tips and tricks that are very useful to remember when doing a single beam survey of any kind. As this webinar is more for existing single beam survey operators, I will not be going through pure basics, but rather just on certain key areas that are very important. Can I have the next slide, please, Boris? All right, so let's start with some principles. Normally, the main concern with any single beam survey is the Z-axis, or your measured depth. For this component of your depth, as seen in the slide, it can be split into 5 different components. These are, like, for example, your tide, your sound velocity, your draft, and also your heave, mainly for high accuracy surveys. And of course, the most important is your raw depth. 3 components out of these are very crucial to remember for any single beam survey. These are your tide, sound velocity, and your draft and offset corrections. So I'll put a bit more focus mainly on these 3 components, just to keep it to a very easy to digest form. So for tide, it is very important that during your single beam survey, any external influence that increases or decreases your water level substantially will be considered as a tide correction. A lot of people get this a bit confused because they think that, okay, if I don't have tide in a lake, for example, I don't need to apply it, but that's not really correct. Sometimes you have influences such as water drainage, that may happen because of man-made reasons. You might have tidal barrages that are open and letting water in and out. So all these usually applied as tide corrections in your software. So it's very important to remember these. Another thing to remember is that for your draft corrections, which is the next thing I'm going to go through, a lot of surveyors always make an error when they are recording their draft in their HYPACK software or other single beam software. It's usually it's because of signage or because of the orientation errors, and it's a very slight error, but at the end of your survey it can lead to very big results that are wrong. So it should be always double checked and cross verified before any survey is done, and also after it's finished. The third of the components to look into is your sound velocity corrections. The sound velocity part is very crucial for correcting for error in different water bodies, because you got freshwater and saltwater, and in certain estuaries you got a mix of both. Sound velocity errors can very much lead to sometimes a few centimeters of error, and also in some very bad cases it can be a few meters. So it is always good to pay attention to this during surveys, and I will explain more on the different methods to do so in the next slide. Can I have the next slide, Boris? Okay, so in single beam surveys, there are usually 2 methods to correct for sound velocity. The first method is to use bar checks. Bar checks usually help to calibrate analog echo sounders, and on HYPACK you also have a virtual bar check utility to correct for raw depth from echo sounders. There are a few different advantages and disadvantages to using bar checks. Firstly, is that it's a simple system and useful when working with analog echo sounders or when you don't have a sound velocity sensor. Disadvantage, of course, is that it's labor and time consuming, and it can be a concern for safety, and the accuracy can depend on a lot of different factors, like, for example, the kind of chain, the kind of rope that they're using, also the movement of the boat as you're doing the bar check, or even current. So if you watch the video that's being shown, it shows a bar check being done at the side of the boat. As you can see, it's not a very safe operation because you got a guy at the side and he needs to know how to keep his balance. He also has to know how to deploy the bar check plate properly so that it goes below the echo sounder. On the inside of the boat, you have the surveyor who will be checking the corresponding values with the physical markings that have already been marked out on the bar check plate and the bar check rope. All right, can I have the next slide, please? All right, the next product that I would like to go through is your sound velocity sensors and your CTDs. These are usually a lot more easier to use and they're a lot more accurate when you're trying to record your sound velocity. For sound velocity sensors, you can get the raw soundings for each profile of depth. So like, for example, you start at your 1 meter all the way down to the bottom of the seabed, and you can easily apply this to your HYPACK software using the sound velocity utility that it has inside. For the castaway CTD, it's a very simple device from SonTek that you can just throw into the water with a rope, or you can even use a fishing rope as can be seen in the photo. And similarly, you can just get the information that you need and apply it to HYPACK straight away. All right, can I have the next slide, please? All right, now that we have covered the crucial depth components to pay attention to, let's just look into another aspect of single beam surveying that you need to be aware and also be careful about, which is shoreline planning and also planning your vessel type. So when doing your line planning, when you're doing for shorelines, it is always important to plan lines that are perpendicular to the shoreline. This helps to make sure that the contours will properly cover the topography around the shoreline. And in some cases, it is very difficult to do perpendicular lines due to shallow shores and also for very narrow passages. So in those cases, it's also important to take note of your vessel type. One example of trying to change a vessel type, instead of using a big boat for these areas to cover the shoreline, you could use a small to medium size USV. Could I have the next slide, please? Right, so for USVs, you have a lot of different USVs that have been coming out in the market over the past few years, and they've been gaining a lot of traction and popularity among a lot of survey communities. All right, there are many advantages to USVs. One is that it's safe and easy to deploy with one person during the survey. And as said earlier, you can have full shore coverage because of the shallow draft. And you can also keep very straight lines on your grid of, for your survey. There are a few disadvantages, of course. One of them is battery life. This has been improving steadily over the years, but of course, there's still a lot more that can be demanded out of it. Another thing is nav equipment dependency. For USVs that are not being remotely controlled and that are autonomous, usually the complexity rises when you have high vessel traffic, or if you have hidden obstacles that you had not planned for before. So these are still being worked on and they're improving every single year, but generally speaking, in the future, it can be quite easy to foresee that 80 to 90% of surveys will start being done by USVs. Can I have the next slide, please? So this is just a short video to show you the RQ port, which is always being used together with the M9. And this can show you how it can keep a very straight line on your surveys. And I do apologize for video being a bit slow if for some of you can't see it properly. But just to take note, just watch how it's able to keep a very straight line and also keep to the line planning that has been put on the screen. So as you can see here, the depth soundings are exactly according to the line planning. It's a lot more difficult if you want to do it on a big boat. You need a boatman who's very experienced, and a lot of times you're not able to get that. So you might not be able to cover certain areas that you plan for, or you might take a lot more time than you needed. All right, so the next slide that I like to go through is mainly for tips on getting a good single beam survey done, and it's just a summary of a lot of other points that I'd like to make before I end my part. There are 2 points here. One is to get your dimension errors resolved, and the other is to ensure you plan your survey well. So for the first point, what I mean is that you should always make sure that all errors in your X, Y, and Z are known, and that effort has been made to correct them to the most accurate level. So an example of this is in the X and Y axis. You got to check what kind of GNSS system you're using, whether you're using GPS or GLONASS or Baidu, and make sure that it's on a high differential setting, or you're using an RTK system if possible. In some cases, if you do not have both, then you can use land-based corrections or satellite-based corrections. Another part which I covered earlier, like I said, is the Z-axis. Make sure that your SV profiles are done, your type corrections are applied. If you need heave, make sure that your heave is applied correct with a high precision or accuracy IMU or motion sensor. So these will contribute very much to a lot of the survey areas that you see. So it's very important to remember these. The second point I would like to make is to ensure you plan your survey well. This is often said, but it's not practiced a lot. And doing things like pre-surveys, making sure you go beforehand to see where your obstacles are, what are the potential hazards that you have. It makes a big difference on your survey time. What can be 1 day of survey can easily become 3 or 4 days if you do not plan it well beforehand. So it's very important to go down, have a look, do a pre-survey, check all these matters before you actually do your survey or even start your line planning. Another thing is bring spares. It is it's a hard and fast rule, and it's been around since the start of people doing surveys. Always bring spares. Check for all necessary items, batteries, cables, inverters, etc. Because I've had situations where we have surveys done in jungles, we've done surveys in the middle of mountains, and it might take 2 or 3 days to get to your survey area, and you don't want to abort the survey simply because you didn't bring a data cable, right? So it's important to check your spares, make sure you have 2 or 3 of each item if you can. Of course, for some items you can't because it's too expensive, but for cheap items you should have as many spares as possible. Also, last and most importantly, always ensure safety for personnel and equipment. There's always another way. Like I said earlier, if you're using a big boat in a narrow river, you don't have to do it that way. You can always get a USV or a small remote control boat. You can do the same survey and you can get a lot more coverage, and you can also reduce the risk to human beings and also to your equipment or running aground, for example. So that's mainly the part. That's mainly the end of my part, and I hope that it's been useful to you so far. I know I couldn't get a lot of things covered for the full single beam survey, but I hope these tips are useful to you. If you have any questions, you can still email me or ask me later in the question and answer session. So before I end, I would also like to do a short poll, mainly to find out the background for all of you, because later for the question and answer session, I will try to gear my answers to you based on whether you're a hydrologist or a surveyor. So just take a few seconds and just select whichever applies to you. Right? So I hope all of you are done. And can we have the results for that? Oh, okay, that's a good mix. And I see that more than half of you are not a hydrologist or a surveyor. So, okay, it still should be fairly useful for all of you. So thank you very much. That's the end of my part. I'll hand it over to Justin to continue.
Okay, thanks, Phillip and Boris. That was really interesting, and We have almost run out of time, but we do have a few questions. So I guess while we have you two experts online, we might as well go through some of these questions. If people have to leave, we understand. Thank you for your time. It's much appreciated, and the recording will be emailed to you anyway. I guess the first one was from Peter, and it wasn't so much a question as a statement. He said, "Hope you guys are all doing well." And so thanks, Peter. We appreciate that. It is strange times, and we are all well at the moment, and hope everyone attending this webinar is as well. The first question I think is probably best for you, Boris. Is it possible to combine an external echo sounder with the M9 so as to display two depths to see the thickness of bottom sediments, for example, in a reservoir or lake?
Yeah, that's an easy question. Yeah, you can. Well, you can connect an external echo sounder to HYPACK, not to the M9, but directly into the HYPACK computer. So you can have as many echo sounders as you want. If you have 20 of them, that's fine. If you want to measure the thickness of the sediment, I recommend, though, maybe not using an echo sounder, but rather a sub-bottom profiler that brings you deeper into the sediment thickness. But yeah, you can run lots of equipment on the same time. That's no problem. That's the beauty of HYPACK. You can, I know people that run a echo sounder, multi-beam, side scan sonar, a magnetometer, and sub-bottom profiler at the same time, and collect everything in one software, which is called HYPACK.
Okay, great. Thanks, Boris. Then we have a question. It's about the processing. Is the smoothing function a requirement? What criteria do we refer to decide whether or not to use the smoothing function?
I think that question is for me.
Yes.
I usually don't like smoothing. Smoothing makes your data look better. Of course, it depends on what kind of equipment are you using. If you are on a lake and you don't have really a lot of waves and your boat is pretty stable, not moving up and down a lot, you don't have to smooth your data. It's all about data quality. Smoothing is something that might help you make your data look better. It tries to delete artifacts at the end of the day. Of course, it's much better to identify artifacts before. So if you know you're going into the sea and you have a lot of waves, get yourself a heave sensor. You can connect that into HYPACK, and it takes the heave measurement and corrects the soundings for the heave. So that will be the better way. But yeah, it's an additional possibility to smooth your data and make. If you make a model, it's always smooth. It's always about the smoothing. So that's what this does. It's smoothing a profile based.
Okay, there's another question that was interesting answer. Thanks, Boris. It's another one for you. Is importing web maps only available when you are using HYPACK 2020? That's the first part of the question. And then, can we use or save the background from the web maps, like OpenStreet, and work offline, i.e. without internet connection?
And the first part of the question is no. HYPACK introduced the web maps in 2019. So if you have HYPACK, if you're running HYPACK 2019, you can use the web maps. Before, no. So HYPACK 18, 17, 16 do not work with web maps. So you have to have HYPACK 2019 or 20. And the second part of the question, yes, the maps, we're actually downloading the maps from the server. It's tiles, it's like little pictures that we download, georeference pictures. So you find them in a directory called HYPACK store on your computer when you have installed HYPACK. So they're all there, yeah, and you can use them offline, of course. That's the idea, because once you are on a survey, you are probably not connected to the internet anymore. So usually you would download the maps before you go into the field.
Okay, there's a question here about the any recommended boat speed for accurate survey. What's your thoughts on that one, Boris? Or even Phillip?
I think it's you shouldn't. It depends on the resolution that you want. I mean, the echo sounder that you have can only ping with a certain frequency. So let's say it pings with 10 hertz, depending on the depth, of course. You want to make sure that you have a lot of soundings at the seabed, so you shouldn't go really fast. So I wouldn't recommend going more than 5 knots, really. And it depends on the area. If it's a small lake, you can't go 5 knots because then you zip zap across the small lake. So you want to go anything between 1.5 and 5 knots. Depends sometimes on the wind as well, and some currents. They might take you away, so you have to go a little bit faster to stay on the line. But yeah, anything between 1 and 5 knots.
Okay, there's a SonTek question here which I could probably answer. What's the best river surveyor upgrade to hydro surveyor if you are interested in cross sections of rivers? And the answer there is you do not need HYPACK or hydro surveyor. You could do the cross sections within the River Surveyor Live software, and you're able to export that, the XY, the lat long, and the depths, and develop your cross sections from that way. HYPACK's obviously a lot more complete in terms of setting things up, but if you're only after cross sections, I'm not sure I would recommend going down the hydro surveyor path. And there's a few other questions. I think that's about all the questions I can see at the moment. So Boris or Phillip, do you want to, any last words to end it on? I think you guys have done really well, and we've taken up our time. So let's wrap this up. If you guys want to say any last words.
Well, I just want to thank everybody for joining this webinar. I think it's kind of useful to do these webinars because people can, we record it so people can look at it later. So I hope you enjoyed it as much as I did. Well, yeah, see you next time, I would say.
Yeah, thank you from me as well. I know that it was quite short on my part, but I hope that it's been useful, and do let us know if you have any questions as well. Thank you very much.
Okay, great. Thank you everyone for taking the time to join us, and all the best and stay safe, and we'll see you next time, hopefully. Bye.
Bye.
Bye.